Hello everyone, my name is Farley Luis, and today I'll be presenting our smart irrigation system, a project designed to reduce water waste in agriculture by combining IoT, sensors, and machine learning. Did you know that agriculture uses about 80% of the total water in the US? With so much water dedicated to farming, we want to use every drop wisely. Unfortunately, traditional irrigation methods waste up to 40% through overwatering, evaporation, and runoff. Our goal was to create a smarter, more adaptive solution. The Internet of Things, or IoT, allows us to continuously monitor environmental conditions like soil moisture, temperature, and humidity in real time. This data gives us valuable insight into what's happening at the ground level without needing manual checks. Machine learning adds the decision-making layer. By analyzing both real-time sensor data and past weather trends, it helps us predict how much water a crop will actually need at a given time. What makes our system effective is how these two technologies work together. IoT provides the data, and machine learning makes the decision. The result is a smart, automated system that doesn't rely on fixed schedules. It adjusts based on the conditions. This ensures irrigation happens only when necessary, helping reduce water waste and improve overall efficiency. Watering needs don't just depend on the weather forecast. They change depending on the time of day, the time of year, and what's happened recently. For example, crops generally need more water in the heat of a summer afternoon than they do during a cool spring morning, even if the forecast shows the same temperature. That's where our choice of machine learning model comes in. We use an LSTM, or long short-term memory network, which is a type of neural network built specifically for time series data, which is data that changes over time, like weather conditions. LSTMs are especially good at identifying patterns across longer periods. So instead of just looking at today's forecast, the model takes into account what happened yesterday, the day before, and so on. It might recognize that if it rained heavily 2 days ago, less irrigation is needed today. This kind of memory makes LSTM a more thoughtful and context-aware model, especially when compared to simpler approaches that just respond to current conditions or a forecast. It gives us a smarter prediction and ultimately a more efficient use of water. To train our LSTM model, we used hourly weather data from Grand Prairie for the entire year of 2023. We focus on weather features that directly affect watering needs, like temperature, humidity, and rainfall. We normalize the data to help the model train more effectively, and we encoded time as sine and cosine values to capture its cyclical nature, like daily and seasonal patterns. The system is built on three key layers: sensing, processing, and interface. We use environmental sensors connected to an Arduino, which communicates wirelessly via RF modules. The Raspberry Pi acts as the backend, handling data storage, running the LSTM model, and retrieving weather forecast. Finally, a website built with HTML, CSS, Java, and Python serves as the user interface for monitoring and control. Let's walk through the flow of our system, starting at the source. First, we have sensors placed in the environment collecting key data like soil moisture, temperature, and humidity. The data is read by the Arduino, which acts as the system's first processor. From there, it's sent wirelessly using RF modules to the Raspberry Pi. The Raspberry Pi acts as the central hub. It stores the sensor data, retrieves additional weather information from an API, in this case tomorrow.io, and runs the LSTM model to predict when irrigation is needed. Once a prediction is made, it's passed to our front end, which is a website designed to display the information in real time. Users can view live insights and, if needed, manually control the irrigation from that interface. We were able to successfully train and deploy our LSTM model using a full year of weather data. It's now integrated into a website that provides real-time predictions, giving users a clear view of when and how much to irrigate. And if needed, they still have the option to step in and manually control the system. Water is not an unlimited resource. By making irrigation smarter, more aware of actual conditions and future weather, we believe the system can play a part in using water more responsibly. Thank you.